The recording has started. Okay, and now I will share my screen. Okay, and also I want to apologize if the intensity of lecture is not the same, uh, because it's really cold here in my office. And there is no heating, and I'm not wearing any sweater because to me the winter has not started yet, but I guess I was wrong. So the intensity is a bit low today, not as the usual lecture, so I apologize for that. uh, it's quite cold here. Okay. Right. Let's move to HTTP. Yes. Okay. We are in the chapter 2 in the application layer, and we plan to cover not all the protocols, but the two very important protocols, which are the DNS. We just covered it. And the HTTP. And the HTTP is a very simple protocol, and I will not cover the basics. I will just skim through the basics, very quickly. But then, after the basics, I actually want to discuss the topic of PLT. That is a very important topic, the page load time. Okay, and improving the page load time. And improving the page load time means actually minimizing the page load time, because minimizing the PLT will mean that the whole user experience of the triple W of the web is improved. Okay, and this is a very important web performance metric, performance parameter. And it's not the detail is not mentioned in the Cross and Ross book, but I have my own lecture slides on this, on the PLT, and that's what I want to discuss in the topic of HTTP. Not the basics, not the very basics of the HTTP, but I will just skim through the basics. Okay, so I'll be a bit quick in the next couple of in the next few slides. But trust me, this is very elementary level content, very elementary level of details, and you all definitely know about it. I'm quite certain. So let's just skim through the slides to start HTTP, and then we will go to the main topic, which is related to HTTP, and that is the page load time. Okay. Okay. Right. So we know that web pages consist of objects, and the object can be HTML file, JPG images, audio, video files, CSS style sheets, Java applet, etc. Okay, and each object is addressable by a separate URL. Okay, whenever you are at the web page and you hover your mouse over a URL, over an object, that object usually has a separate URL. Okay, so we can do it right now. If we just go to a web page, let's say, I don't know, this is my overleaf, and if I hover the mouse over here, and you can see in the address bar below, there is it's mentioned that it has a separate web addresses, and then let's say this one, all of those, and all the links, all the CSS style sheets, all the even a small icon, everything has a separate URL. It's addressable, and the web page consists of typically a base HTML file, and the base HTML file, which is index.html, it includes several referenced objects. So typically, when the get queries is made to a particular server, the first response is the base HTML file, and then the user at the user end, the browser started parsing the base HTML file, and when it is parsing the base HTML file, it sees that, okay, to load this HTML page, this web page, I will have to do certain more queries. Okay, and because the base HTML file contains the references to the other objects. Okay, and then these all these objects are requested later on, and then the whole page is rendered in front of the user. Okay. This is the model, the overview of HTTP. It's a hypertext transfer protocol, client-server paradigm, and the clients are running on their own machines, and they request the server. So elementary detail. So request response, request response. Okay. HTTP uses TCP because HTTP needs RDT, reliable data transfer. So it uses TCP at the transport layer. The port 80 is used, dedicated port 80 is used, and the server accepts the TCP connection, and then the whole exchange take place, the whole exchange of the web page, and then the connection is closed. Okay. Sorry. HTTP is stateless. The server does not maintain any information, but HTTP can be made stateful with the help of cookies. Okay, we will see in few slides. Yes, HTTP connections. HTTP connections can be non-persistent and can be persistent. So just like the name suggests, the non-persistent are the connections which are, non-persistent. So na rehne wale, which means that these connections, they terminate and at most one object sent over a TCP connection. This is the older version of HTTP. Okay, this is no longer in use. It has a very poor performance. It has a very poor page load time, because only at most one object is sent over a TCP connection, then the connection is closed. And if you want to download multiple objects to render a web page, you require multiple connections. So obviously, very basic and rudimentary approach which was taken in the early days of WWW. I mean, maybe in late 80s or early 90s, and then obviously the performance as soon as the World Wide Web started to expand, the performance of this non-persistent HTTP was very poor, and the PLT was very high, and then they moved to the persistent HTTP. And the difference between persistent and non-persistent is only that the TCP connection is persistent. It is maintained. It stays there. Multiple objects can be sent over a single TCP connection between client and server. Okay, so this is all the details is very simple. I'm moving a bit quickly. Okay, so let's have a look at the at one of the example, at a very simple example. So suppose a user enters a URL www.someschool.edu, some department home.index. Okay, this page, it contains text and a reference to 10 JPG images. Okay, so it contains a base HTML file having some text and a reference to 10 images, let's suppose. Okay, so there are 11 web objects. Achha, very important, please note that a separate HTTP query and response is required for every web object. So if there are 11 web objects on on a single web page, and we need to fetch 11 different web objects to render that web page correctly, we need to have 11 separate HTTP requests and 11 separate HTTP responses. In the case of non-persistent, we also need to have 11 TCP connections, one connection per web object. But in the case of persistent HTTP, we will just maintain one connection. It will stay there. It will be a persistent connection, and all the 11 web objects will be retrieved. Okay, so the process is shown over here. HTTP client initiate the connection on port 80. HTTP server accept the connection. Let's be a bit fast. And the client send the request that, okay, I want to get this web page. The server receives the request and then sends the message to, back to send the message to the client, and then the server immediately closes the connection. This is a non-persistent HTTP. Okay, after sending, it immediately closes the connection. The client then receives the response, and it receives the HTML file, the base HTML file. After parsing the file, it realized that there are 10 referenced JPG images, and then the whole process is being repeated from step 1 to 5 for each of the 10 JPG images. This is non-persistent HTTP. You can imagine very poor performance. Okay, so this is the whole process depicted here. Please note, these sort of diagrams will come very often. Okay, this is the first of its kind. So let me just tell you that this is what we call a time sequence diagram, in which time runs from top to bottom. Okay, and it is very common in networking to depict the performance of your algorithms, or the working, the way the messages are exchanged, in the form of a time sequence diagram. So you can see that at time the client initiates the connection. The server, after this what is this? What is this? When the arrow is moved from here to here, this is half RTT, half of the round trip time. The half of the round trip time is what is required for the client request to reach towards the destination, which is the server. And then in the next half RTT, in the next half of the round trip time, the server responds with the with the with the with the with the acceptance of TCP connection, and now the connection is established in one RTT, and in the next RTT, in the first half of the next RTT, the client requests the file and the server respond with the file, and this black shaded area represent the time to transfer the file, because there is no shaded area over here, over here is because the request for TCP connection and the response for TCP connection and the request for the object, these are all very small in few bytes, but we are assuming that okay, the file may be of some size, so we are saying that there will be time required to transfer this file. So the total time will be 2 RTT, 1 RTT for the TCP connection and 1 RTT for the HTTP request and response plus the file transmission time. Okay, so 2 RTT plus FTT. Okay, and this is the case of non-persistent. And as we know that when this file is being passed over here, okay, now the connection is closed, but when this file is being passed over here and it contains 10 separate JPG images, the whole process is going to be repeated, and the total it's not mentioned in the slide, but you guys can calculate. In the case of 11 web objects, the total time will be 22 RTTs plus the file transmission time. Okay, and if it would be a persistent HTTP, in that case the server leaves the connection open after sending the response. So right here, after sending the response, the server do not close the connection, and then after passing the file, then the next request, response, next request, response, next request, response, up to so on. Okay, so the difference is the time required to establish the connection again and again, and that is basically 11 RTT. So out of 11 RTT, only one RTT, only one connection, and the remaining 10 will be saved. So the total time in that case will be 12 RTTs. Okay, and so in this case it will be 22 RTTs, in this case it will be 12 RTTs. But anyway, if you don't get this, the most important difference is what is mentioned over here. Server leaves the connection, subsequent HTTP messages are sent over the same client server, and the client send request as soon as it encounters a reference object. So it is parsing the web page. Right here it is parsing the web page. As soon as it sees that the web page contains more reference object, it keeps sending the request and then the response from the server side. Okay. Any question up till here? So this is these are very elementary details, very basic differences, very basic introductory detail of HTTP, and then the two versions of HTTP. One is non-persistent. It was there in the late 80s, early 90s, and obviously very poor performance. Only one connection, only one object per HTTP, and so for each object you require 2 RTTs, one RTT for the connection and one RTT for the object retrieval. Okay. So it was soon replaced with the HTTP, with the persistent HTTP, and this version was called HTTP 1.0, and this version is called HTTP 1.1. And then the pipelining came into play. So we call the next version, which is still in use right now, the HTTP 1.1p. So HTTP 1.1 with pipelining. I will discuss in few slides what is pipelining. But anyway, so these are the versions, and then and nowadays browsers have started supporting the latest version, which is also called Google's PD, HTTP 2.0. Okay, there are some few improvements in the HTTP 2.0, but not a lot. We will discuss it as the closing remarks of the HTTP topic, not today, but maybe tomorrow. Okay. So this is the request message of HTTP, and you can see that it's a human readable format, very simple, very plain ASCII text. So it's a request message. So the message which is sent from client to server. So get this page. The version I am running is HTTP 1.1, which is persistent, and carriage return and line feed. So basically next line, and the host is this www.net.cs.umass.edu, and the user agent is Firefox version this, and blah blah blah, all these things. Okay. Keep alive is used because the version is 1.1. So if the version is 1.0, it's non-persistent. The keep alive time will be off. Okay. So connection is keep alive. Okay. And then the certain languages accepted, encoding and character set and all those things. So these are details we don't need to understand each and every line of the HTTP request message. Okay. And the request message can have certain sorry, methods: get method, post method, head method, and methods like that. Okay. And then this is the general format. This was one particular example. This is the general format. Okay. So we have a method over here, then the space, method, then space, then the URL, method space URL, then space version, method space URL space version. Okay. And up to so on. And then the next line, header field value, header field value. So there are several lines and different header fields and different values. Okay. Very generic and very simple message format. Okay. And certain methods, let's skip those methods. 1.0, there were very few methods. 1.1, we have some more methods like put and delete. Let's not go into the details of all these. This is more like, the course of web engineering, not like networking. Then the response is this one. You have the response HTTP. Then there is a status message. Okay, 200 OK, 304 not found. You must have seen those status messages. 404 not found, 304 redirect, 504 server error, internal server error, things like that. So these are the status messages. Okay, date and all those things, and server. What is the server? The Apache, and the version, CentOS, last modified e-tag, and things like that. And then the data, the requested HTML content, the web object is over here. Okay, after the header. This is the response header, and the one I showed, this one is the request header. Okay. These are the status code. 200 OK is what we like to see. Request succeeded. 301 move permanently. 400 bad request. 404 not found. We tend to get this one sometime. 505 HTTP version not supported. 403 redirect, internal redirect, server internal error, and many others. Okay. So all of these are the status codes. Okay. Okay. Okay, they are asking us to do a very small exercise, and this we can do right now because it may be a little bit interesting for you guys if you have not used Wireshark before. They are asking to telnet, but I won't be doing the telnet, because if you go to command prompt and if you telnet, then the reply will be that the telnet is not recognized as an internal or external command. What you need to do is that you need to go to the Windows feature and you need to turn those feature on. So here it is, the telnet client. You need to turn it on and then restart the PC. So this command will work, the telnet command. Okay, we don't need to do this. I just need to show you the Wireshark capture, so we can do it without the command prompt. And if you guys want to telnet, you can come over here in the Windows feature. You can turn this one on and then restart, and then the telnet command will work. But instead, we should do something like that. We should go to the browser, and let's say we just write gia.cs.umass.edu. Okay, so let's just write it over here. GAIA. I have done it before sometime, and before doing that, let me start the Wireshark. You guys should install Wireshark. It's a very interesting tool. It captures the packet. We should go to the Wi-Fi, okay, because I'm using CX Wi-Fi right now. So it's capturing right now. Okay, it has started capturing. So let me press enter, and I stop capturing, and then I apply the filter of HTTP, because there are so many responses. And well, I did it before the class, so it's picking the web page from my cache. So not a good experiment. We can try something else, I think. We can try, let's say, okay, so let me first stop, remove the filter, and then some other web address, let's say or I need to empty my cache. But let's write some other web address. Let's write www dot I don't know, www.polito.it. I don't know, maybe I have opened it before, maybe it's still in my cache, but let's try this, www.polito.it. And before doing that, let me start capturing. I don't want to save this one, and press enter. And the page is being loaded over here. And that's enough, I think. So I can stop the capturing, and now I apply the filter, HTTP, and you can see over here. So we have this one. You can see that this is the method. Well, I don't know why the GET request is not shown, but anyway, I'm just giving you an overview of the Wireshark. So you can see that the Wireshark, it basically captures packets on your right at your NIC, at your network interface card. So it's like a photocopy machine. It makes photocopies of all the packets coming in and coming out, going out of your Wi-Fi interface or your Ethernet interface, whatever mod you are using at the layer 2. And you can see that at this is the layer 2 detail, and then the layer 3 IP detail, and then the transport layer detail, and then this is the application layer detail. And you can see that this is more or less the same message that we saw for the request. And then if we see at the response, you can see the response is over here. So the version, the status code, and in the request you can see that we have the method, the version, and then the client and things like that. So if I take you back to the slides again, you can see that this is the response. It was the same I captured in Wireshark, the version, the status code, and other things. And then the request, again, the method, the URL, and the user agent, and other things. Okay, all these can be seen over here. Okay. So you see, accept language, accept encoding, and connection keep alive, and all those things. Exactly the same that like we saw here, and the response message is also is something like that over here. Okay, the E tag, the expired, the last modified, the content length, and all those things. Okay, so it's over here. The E tag, the everything. We don't need to go into the detail of each and every field, because this will take a lot of time, and it's not really a very important networking concept. You can Google all those things. So the E tag and the last modified, they are used for caching. Okay, and the keep alive is used for the persistent connection and other things. Okay, so all these header fields have some meaning. Okay. So we have done this little experiment. You can do it with Telnet as well. In that case, you need to turn on the features of Windows Telnet service, and then do it from the command prompt. Okay, but do install Wireshark. I think most of you know this tool. It's a really good tool, very interesting, and we may try to have a lab maybe on it. I don't know if what will be our mod in future, but I plan to have a few labs in the second half of the semester on Wireshark and on NS, and maybe Cisco Packet Tracer or ENSP from Huawei. But now I don't know if we go into the full DL mode, then maybe we will be having these labs in the form of just like the one I showed you right now, or maybe maybe in the form of short assignments after a demo from my side. Okay, well, cookies can be used to save the state, and they work something like that. So for example, if the client request, very simple concept, when the client requests something for the first time, so you can see that at the client end there is already a cookie file, and it has a cookie reference for the eBay website. But let's say the client is first time trying to access the Amazon server. It's the first time. Let's say it's a usual HTTP GET request message, and because it's a new client, the Amazon server creates an ID for the user, and it's 1678, and it creates the entry at the backend database as well. Okay, for this new client. Okay, and when it gives the response, with the response it says that set cookie 1678. Now this can be this you can see in the Wireshark if you are really accessing a website for the first time and the website actually uses cookie. You can see this command in the ASCII human readable format in Wireshark in the capture of the packet, just like I show you guys few minutes ago, and you can see the set cookie from the server, from the HTTP response coming from the server. Okay, okay, you can see this if you're really accessing the website for the first time. You can see it right here. Okay, the set cookie. But right now, possibly I have accessed www.polito.it before, so the set cookie command cannot be seen over here. But for the first time, if you visit a website, you can do this experiment. You will see this command. Okay, and when the user is the client receives this response, it will maintain this cookie Amazon 1678. Okay, and then let's say after some time, the client, when it requests the HTTP, they request the server again, it will send this cookie, the reference of this cookie again. And because you see, when you visit the website, they all generally ask you that we use cookies to improve user experience. So you either accept that, or the website continues saying that by continuing the use of the website, you are agreeing the privacy agreement and the use of cookies. So basically, when you agree, you send the detail of the cookie in your own request. So if you don't send this, you will not be able to have the cookie specific action. If you delete this from your backend, this is under your control. If you delete it from your backend, this will be again a usual HTTP query, and then a new cookie will be generated. Okay, so the server will not know who is the person contacting me. I mean, in case you are not logged into your own account, like in the case of Facebook or Twitter or things like that. Okay, because the account itself is another thing. It has a, you know, really sorry, this cell phone. Okay. So let's say 1 week later, again, if you visit you will again receive. So I mean, this file is being maintained over here. The backend database entry is being maintained over here. So whenever the user will visit, it will receive a cookie specific action. And this is the same when that you observe when you sometime visit a website and you see that the website, it seems like it knows me. It knows what was the activities I did previously. Okay, so you went, if you did a t-shirt search on Daraz.pk, you are likely to get a similar sort of what do you say, recommendations the next time you visit the website. Okay, so cookie is definitely an infringement in privacy, and definitely you are supplying some. Yes, please.
Yeah, sir. Actually, I was asking that. I mean, you're saying that set cookie can reside only for 1 week in a browser.
No, 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 no. This is just an example. That 1 week later, again, if you no, no, you see, even 1 week later, the HTTP request message has the cookie name. The cookies will stay there. I think. I don't think they have a specific TTL, a time to live. They don't expire.
Oh.
They stay
So
there
no
at the
matter
back
how
end, and they
many,
stay.
yeah.
Mm-hmm.
Okay. No
Yeah,
matter
the
after how
cookie
many
file.
years you access the website, like, will they be still there?
If your system configuration has not changed, you are using the same browser, you're using the same Windows, and every little detail is intact, I believe there will be no change. You will still use the same cookie to access the website. Okay.
Okay. Okay.
Yeah.
Thank you.
You're welcome. Okay, well, we know that it has many uses. Okay, so it do make our experience better, but it's at the same time it's a privacy infringement as well. So it's up to users if they want to maintain that file, if they want to delete, clear cookies from the caches, it's totally up to them, because the client side is under your control, okay? And then whether you accept or not, it is also under your control, okay? Because they always ask you, it's mandatory from the IETF, Internet Engineering Task Force, for any website which is using cookies, to ask the users whether they want to accept it or not. So, but they are used for shopping carts, authorization, recommendations, session maintenance, and things like that. Okay. Okay. From here, I want to shift to the other set of slides, and I will just start this topic, and just give me 5 minutes, and then I'll take this topic. I'll continue this topic tomorrow, and we'll finish tomorrow the chapter 2. So I told you guys that I wanted to discuss HTTP mainly because I want to discuss this very important parameter, which is the PLT. Okay, it is a key metric. It is a key performance metric for the World Wide Web. Okay, so simple definitions: the page load time from the time the user clicked and sees, and then the time the whole page is rendered. So you press enter or you click, whatever you do. I mean, the time when you initiate the request or the HTTP GET request of the index.html page, and to the time when you see the page, rendered fully in front of you. That's the PLT. Okay. Obviously, it depends on many factors. It depends on the content and structure of the page. Okay, whether you are using compression, whether you are using optimized images and content, and whether your page is very well structured, and things like that, and what sort of content is on the page. Is it a very heavy content, or is it simple static images, or CSS style sheets, things like that. What are the protocols involved? Whether you are using the HTTP version 1.0, you're using the HTTP version 1.1, or even better 1.1 pipeline, or Google Speed 2.0. Okay, so what are the protocols involved? Okay, and then the network bandwidth and the round trip time, definitely. So I mean, the bandwidth that you are connected with, and the server that you are accessing, is how distant centralized that server is, how much is the total RTT from your end to the server end. So all these factors are important, and they play their role in the overall page load time of any web page. Okay, not this one, but I would like to discuss this, and then I will conclude. Okay. So how to improve PLT? We will discuss 4 different methods, not today, but tomorrow. We will discuss 4 different methods, and I just want to highlight these methods, so that I will just start discussing, right away tomorrow at the beginning. So how to improve PLT? There may be several methods. There may be several methods to improve PLT, but in this course, the methods that we will be discussing are these 4. Okay, and because the reason is that the other methods are quite obvious. I mean, if you increase the bandwidth, I mean it is the most obvious method to improve PLT. Okay, at the access side, you have a certain level of SLA, you buy some bandwidth, and if you improve your SLA, your service level agreement with your ISP, and you increase your bandwidth, definitely you will have a improved user experience of the World Wide Web. Okay, but other than the obvious methods, these are some of the more sophisticated methods, which because obviously increasing bandwidth is a costly proposition. Okay, so it's not that simple. I mean, if that you just simply keep doubling your bandwidth every year. No, it's not that simple. Okay, if NUST is right now having 800 megabit per second from Perl, I mean, doubling it would be a very costly proposition. But so NUST should go for some other options as well. I mean, it will try to delay the increase of bandwidth option as much as it can. Okay. So the other options are these 4, which we will discuss. There may be more, but we will discuss these 4 options, and these 3 in great detail. These 3, because these 3 are the options which are directly related to the networking course. Okay, the first one, it is not directly related to the networking. The first one says that you reduce the content size for transfer. So this is more related to web engineering, not networking. It is more related to web engineering. Okay. Okay, the IT and CS guys, you must have studied the course of web engineering or web development, and you know that designing a web page is also an art. So you want to use smaller images, you want to use compression, and and also the way the page is rendered. So whether you are rendering the I mean, most of the web content is makeup of images. Please note. So according to some surveys, 60 to 70% of the web objects are images. Okay, 60 to 70% of the web objects are images. So that's a huge number. Okay, and to support this claim, I ran some tests before the class, and you can see that if we notice over here, let's have a look at when I use the pingdom website, and I am testing the URL of nus.edu.pk, and I am testing it from North America, San Francisco. Okay, so someone in San Francisco, if it test the URL of www.nus.edu.pk, what is the result that they will be getting? So our page size is this one, 14.6, and if you notice, and the page load time is 10.24 seconds. That's a lot of time. Okay, so a user in San Francisco is not getting a very good experience when it is loading www.nus.edu.pk. But anyway, if you dig deep into the details, you will notice that the image content is, in terms of percentage, it is 87.32%. Okay, and in terms of request by content time, this percentage is still high. So that means that if we made a total request of 107 total HTTP request to load this web page, out of those 107, 56% request, which means 59 total requests, were for the images. That's a lot. Okay, so this is the same for all of the web pages. You can check these tricky little tools in your own time, and you will see that for the other web pages as well. What I wrote over here, these surveys are mostly correct. So internet, it is made up of a lot of images. Okay, so if we use smaller images, if we somehow optimize the way they are being rendered. So for example, one way is, you must have noticed that one way, now it's not in FTF mode, so you cannot see me, but try to understand what I'm conveying here. You must have noticed two different rendering techniques of the images. Sometimes a web page is being loaded and the image is being rendered top to bottom. Okay, and sometimes web page is being loaded and the image is being rendered in an embossed manner. So for example, first a very low layer of image, a 144p, and then it gets a little better. It's blurry in the beginning, and then it gets a little better, and then better, and then better, something like that. So even these little details are very important in the user experience. So I mean, some user perceive the top to bottom rendering of images as better, and some perceive that, okay, I have started to see something. Okay, now it is getting better, now it is getting better. So it depends. It's there is no clear winner, but the point I'm trying to make here is that you do put some effort in the way you design your web page. Okay, so Nest do need to put effort in the way this web page is designed, to make sure that a good user experience is observed around the globe. Okay, and for that, these are some of the techniques. So this is all we will discuss in the first step, and the remaining step we will discuss in detail tomorrow, because this is not related to the networking, but I have spent a good 4 or 5 minutes in explaining how this can play a role in improving the PLT. Other than that, changing the HTTP using persistent connection and using pipelining, this is something related to networking. Changing HTTP to avoid transfer of the same content using the caches and web proxies, this is again a networking related technique of improving PLT. And moving the content closer to the client, so use of CDNs, content distribution networks, this is again a very important networking technique which is used these days to improve the page load time. Okay, I'll stop here, and we will start from this particular slide tomorrow. And if there are any questions, please, I'll take them right now. Do let me know if there are any questions.
Yeah, sir. Actually, I wanted to ask about the page redirects.
Mm-hmm.
Yeah, I
Yeah,
mean,
page
you also.
redirects are also something which you don't want to have. So, for example, uh, it's giving us this ping DOM is giving Nust some improvement suggestions, and one of this is to avoid the URL redirect. So, when you are redirecting the URL to some other location, basically you are including another DNS query, and you are including another HTTP query response. So obviously this will add some more delay to the actual rendering of the page. So this is something that should be avoided to ensure an improved PLT.
Okay, thank you.
Any other questions, G? Anyone has any question?
Sir,
I do
this
have
is a
some other. Yes, please.
sir,
Please,
this is
please.
a pretty
बताइए.
basic question, but
Yes.
I was
No
hoping you would
worries, no worries.
clarify.
Right?
Um,
Sure, sure.
you're talking about cookies helping keep state. So, what is the definition of this state over here?
Okay, this state is what is maintained um, right here. Okay, that's it. That's the state. The state is um, uh, some basic knowledge of the user, accessing our website. So against a specific cookie, they have, in their own way, they have maintained a session detail of, what the user was. This is exactly what a state means. So the server actually maintain a session, a state of a user, and when the user visits the website next time, it responds not with the usual with the usual response. It respond in a cookie specific way, which means that the server somehow tells the user that I know you, and this is something that you did last time, and these are my recommendations for your this session, for your new session. So the state is something, I mean, that you maintain for any particular event or any particular person. Okay, you maintain that, okay, I met this person in Seeks, or let's say in my office or somewhere. This is the state, the what you have with your at your backend database in your mind. Okay, the state that you have maintained about me is, okay, our networking professor taught us network switching and routing. I mean, just a reference for the future. That's it. Okay. It can be maintained in any way via a session ID, and then the session ID is mapped further to the details, and or something else. Depends upon how big is the size of that organization. I mean, Amazon can afford to manage a very detailed state of a user, while the others, they may not maintain a very detailed state. Okay.
Okay, thank you.
Have I answered your question or not? It's
Yes,
just
sir.
a reference for the future. It's just a reference for the future. Okay. Any other questions, G? Okay. Well, then I can stop the recording. You can sign off or not.